Hello, everybody. Hello. Can you hear me at the back? Am I all right? Loud enough? Yeah? Good, good, cool. So thank you for coming to this talk, Progressive Web Apps. I heard there's some other meetups going on tonight, but you don't want to be there. This is the place to be tonight. So let's get started. Who am I? My name's Dean Hume. Like Rachel, I am a Google developer expert, but we're not going to ram too many googly things at you. I also work at a company called Huddle. I work as an engineering manager there. So, what is a progressive web app? It kind of feels like every time you look and close your eyes and look again in front-end development, there's something new being thrown at you. And all of a sudden now there's progressive web apps. But in the simplest terms, a progressive web app is really moving towards being more native. So this quote is quite nice. A progressive web app uses modern web capabilities to deliver an app-like user experience. And we're going to learn exactly what that means as we go along. Click. So the idea behind progressive web apps, there's some core drivers. First of all, they should use URLs and links. They shouldn't be any different to the web that we all build on. They also need to be able to access the system capabilities. So the things that native apps can do, like accessing your camera, being able to access the Bluetooth, all those sort of things, that is coming to the web. Not only that, it's accessible. It's accessible to our users and accessible to us as developers. Nothing changes. All the things that we do, the way we develop, this is all really part of it. And best of all, it's free. You don't have to go to an app store and download it. It's just a website. I really like this quote by Alex Russell. He's one of the team that actually worked on the original spec. And he says, these apps aren't packaged and deployed through stores. They're just websites that took all the right vitamins. So it's like extras, you know. It's like steroids, sort of, in a good way. And they're awesome because there's no install needed. You don't need to download anything. And it's built on the fabric of the web. And believe it or not, you're already using them. I don't know how many of you use Inbox at the moment. Inbox, yeah. Inbox is a progressive web app. Under the hood, if you start digging and you fire up your console, you'll see some progressive web action in action. But what does this actually mean for our users? You know, we come to these meetups and we learn about all the cool features we can add. You know, there's some great things out there. But what does it actually mean at the end of the day for the users? Because this is who we're building it for, right? But it means that our apps can get more engaging. They can be faster. We're at the web performance group, right? We've got to be fast. And we've got to be more reliable. So bear with me for a second. I'm going to break this talk down, and we're going to cover it into 4 parts. So this talk is going to really talk about what are progressive web apps, and what are the tools and the things that you can use to unlock the capabilities. How do you use them to engage your users? How do you make your websites faster using them? And how do we make your websites more reliable? So let's dive into the first part and understand what progressive web apps are all about. Now, you may have heard this term floating around on the web, service workers. They're really the key to unlocking all the power in a progressive web app. All they are is just a simple JavaScript file, and it runs on another thread in the background. And the best thing about it is it's been described as an air traffic controller. So again, I'm throwing loads of quotes at you tonight, but think of your web app requests as planes taking off. Service worker is the air traffic controller that routes these requests. And the service worker lets us tap in to an event called the fetch event. And this is anything coming and going. Every time you make a request for an image, every time you make a request for over the wire, just an AJAX request, that is controlled, and we can tap into that. So this really unlocks a load of possibilities for us as developers. I'm going to play you a little video. I don't know how many of you have seen this before, but I'll play it anyway, and I hope the sound works. It's a bit Hollywood, but whatever.
For too long, users have been left staring at a white screen. For too long, they've been let down by the cruel seas of network connectivity. And for too long, we've been powerless to help. We've been left waiting. But no longer. A new browser feature has arrived. A total game changer. A feature that Introducing the service worker.
Yay! All right. Anyway, back to normal service. So, service workers, after all that drama, have been described as the perfect progressive enhancement, actually by Bruce Lawson, who's coming here in a few weeks, I think, months, maybe. Maybe. And the reason they're the perfect progressive enhancement is because if your browser supports it, you can use these features. If it doesn't, well, it doesn't matter. You don't have to, start getting a little crazy and think, oh, well, I've got to build all these extra things to work or not. You just, if it's there, it'll use them. And you'll see how in a few slides. So how do they really work? Well, we've talked about the concept of an air traffic controller. But behind the scenes, imagine you've got, okay, I've got a Chrome logo there. That's the Chrome browser, right? Going to the server. The service worker sits on the separate thread. So it's just a JavaScript file. You just register it. And it goes through different stages. So when you register the service worker, it installs itself, and then it's ready to use. Now, the idea behind it is it doesn't normally, there is ways to get it to, but it doesn't work the first time you hit the site. It has to work on reloads. There is some sneaky tricks, but they're trying to get it to work a bit better with that. But right now, because it sits as this middleman between the server, it allows you to intercept things. If something's going out, we can alter it before it goes to the server, send it to another server if we wanted. When it comes back from the server, we can play around with it a little bit. We could add some headers on there. We could just stop the content coming back completely. You have total control over everything coming and going. You can even decide not to return anything from the server. And we're going to look at a pretty cool technique in a second. But that's why they need to be HTTPS only. Because imagine how much power you could give to someone if you managed to inject a script that was malicious. They'd be able to redirect everything, and you wouldn't be able to see anything happening under the hood. So it needs to be HTTPS. And I'm sure you're thinking, HTTPS, this is a bit of a barrier to entry. That really sucks, right? Well, it doesn't, because there are companies out there that are offering. There's others. I don't work for Cloudflare. I'm just putting it out there. Cloudflare has free SSL. You can sign up for it. You just point your DNS to it, and ta-da, it's all handled for you. It's not like the best security, but it's pretty good if you want to start playing around with this. Also, if you use GitHub and GitHub Pages, you can deploy to GitHub and then push out a page, and you get HTTPS by default. You do get the GitHub domain, but it works really well. And yeah, free. It's free, baby. Come on. Anyway, so service workers really are the key to unlocking all the power inside your browser. And you're probably thinking, yeah, but what's the support like? Well, the support is better than you think. Chrome, Opera, and Firefox currently have support for most of the features. At the recent Edge Summit, they announced that they are going to start working on it. So service workers is in the pipeline, so it's coming. No one really knows what Safari is doing yet, so we'll see. But when it comes to building progressive web apps, there's a few different approaches you can take. There's something being described as the app shell architecture, so the application shell architecture. And we'll have a look at that in a sec. And then you can also take an approach where you really just pick and choose the features. And this is how I started learning. I just fired up a GitHub repo, played around with some service workers, and just tested the features that I wanted to use. Think of them as, in the start we described them as the vitamins. These are just the vitamins that you want to take. But let's quickly look at the app shell architecture. I'm not going to dive into it too deeply. I'm going to provide a link in a second. But the app shell architecture, so if you have a look on the far left, you'll see it says app shell. You've got the header, and you've got a little background in there. This really works well when you are loading dynamic content, so content that's coming back and changing. Say, for example, you had a news website. The idea behind the application shell is that you can cache it so that someone instantly, when they visit the site again, they instantly have that shell there. Even if they're offline, the shell is still there, and it lets them know that something's happening, and when you get connectivity again, you can show them. And then when the connectivity comes in, the content can be loaded. Now, this is a pretty in-depth idea and concept to run through. I've just briefly scanned over it. But if you want to learn more about it, I've created that shortened URL. And I will be sharing There's going to be a lot of URLs coming up. So I'll share these slides with you, and you guys can just have a look at them afterwards. But being a bit lazy, I just like picking the features that I want to use. That's the cool part. You just go, well, I want to use that, so let's add a surface worker in and use it. There is a great list of progressive web apps that are currently out there on the web. This is actually on the Opera Software GitHub repo, and you can check it out. A lot of them have been created by people from all the different teams, the browser teams. Ooh. So we've covered section 1, just understanding what service workers are all about and progressive web apps. We've talked about why they need to be SSL only, and we've talked about how you can approach the 2 different architectural styles with it. But let's talk about the second section, how you can actually start using it and engage your users. And we're going to look at some code examples and dive into some fun things. And I've broken down this into 3 sections. First of all, the look and feel of your site. Because we're moving towards a more native-like feel, we want to be able to get a look and feel more like native apps. We want to also engage with our users using push notifications and adding to the home screen, that same sort of capability. So, what about the look and feel? Right now, in your browser, you can achieve this effect. You see on the left-hand side, there's a gray address bar at the top. You've got the blue one on the right-hand side. This can be done now without any service worker reaction by simply adding these tags in your head. You can, for Chrome, Firefox, and Opera, you can add a theme color. Same for Windows Phone and Safari, and that'll affect the way things look. But we want to take this a little bit further. Actually, before we go on to taking it a little bit further, this is actually a link that'll tell you all about those and the different settings you can use. So that's in there. But we want to take this a little bit further. And this is where the manifest file comes in. So now a manifest file is just a JSON file, and it has loads of settings in there that allow you to control how you want your app to appear to the users. This looks a little confusing when you first see it. And I know there's a few errors in here, but let's, for example, talk about the background color. So instead of setting the background color how we did, you could always decide to do it this way, using the manifest file. There's a number of other settings in there. Whoa. There's a number of other settings in there. I won't go into them just yet because we're going to look at them as we go through the slides. But for example, if you were to set that, this is what it would look like on an Android phone. Oh, I messed the GIF up. Now, and if you click the air horner, it goes blue, and then you actually load the app. I know this is very, very simple stuff, but it's the start of what will become your app. Next up, you can start to add things like standalone, and that says, do I want to hide the browser back and forward buttons? I want to add some icons, so when I add it to my home screen, the icons start to appear. What about the start URL? And what about the orientation? If you wanted to, say, build a web app that was a game, maybe you wanted a landscape instead of portrait. It's all up to you now, and the power is in your hands. I sound like Patty McGuinness, don't I? Anyway, when you have a manifest file, you simply link to it in your head. And you put that in there, drop it in there in your manifest file. I called it simply manifest. You can put that whatever you like, really. And the manifest file, if you want to learn more about that, this goes into more detail. This is a shortened URL, something for you to check out. But when it comes to manifests, and when you first look at them, you're like, I'm dealing with JSON. Did I change something, or was something wrong? If you get something in the wrong place, you can mess up the whole file. There's actually a web app manifest generator. I actually think Bruce Lawson wrote another one that's somewhere, but this one's better. And you fill in the details. You can add your name, the start name. You could add the orientation, and it will just generate the file for you. So pretty easy stuff, ready to get started with. All right, let's get into the more meatier stuff. What about push notifications? So we've had WebSockets for a while. We've had the ability to push to the browser, but we haven't quite had what the notifications that you get when you say you have a native app. I don't know if you've started to see Facebook on your Facebook notifications. When you fire up Chrome, if you use Chrome as your browser, you'll start to see them appear in the bottom right-hand corner anytime. Has anyone noticed that appearing lately? So that is actually the push notifications starting to come through. And as you can see in the top right-hand corner there's the notification and something at the bottom. But there's 3 steps that need to happen before you can just start doing this. First of all, we have to ask the user's permission. The user has to allow it. We can't just start spamming them and sending them messages. Once they've subscribed, it generates an ID, and that's their unique ID. We then need to save that ID somewhere. Generally, you save it on the server so you can use it when you want to send them messages later. And then when you're ready to send a message, you can send it from Google Cloud. So it just goes straight out. At the moment, I think it actually can only be sent from Google Cloud. I know that they'll start to open this up at the moment, but right now, it's still pretty new stuff. So right, the second step, we need to subscribe the user. So now we've got the user's ID. They're coming through. And what we need to do is start getting into some code. So I'm not going to go too crazy with code, but this is a JavaScript file. And what we want to do, this is a JavaScript file that is going to register our service worker. So we're just saying, hey, if this browser supports service worker, we're going to do something. If it doesn't, well, then it just won't do push notifications. Once we've registered our service worker, we're using JavaScript promises. I don't know if you can see over there, it's got the then. We're passing through this registration object. And if our registration was successful, we can then go, hey, we want to push this through. We're ready to go. We've got a subscription back. And that gives us back something and lets us know that we can then save the subscription. Now, I know I'm going through this pretty quickly, but there's really in-depth tutorials and ways to go through this that you'll see. And once we've got that subscription, we've got the subscription ID, we can save it and send it to the server. I've called this send subscription to server. That's a function. That could be anything you wanted, really. It really just needs to post it to somewhere that you want to save this. And then once we're ready, we can send it from Google Cloud. And if you wanted to test this right now, it's free to sign up. I think you get like 10,000 messages for free or something like that. You sign up for Google Cloud Messaging, you create a new project, and you can start using this straight away. Once you have that, you then get a little, I think it's called the Cloud Messaging ID that you get as part of your project. And you can add it to your manifest. Because remember, the manifest is it's telling us where everything's going. So the manifest file, we just add it down at the bottom there, GCM sender ID. And that's ready to go. Cool. So I kind of went through that a bit quickly. But if you'd like to read more about this and find out some more, there's Google. I've created 2 shortened URLs. Google have got a really in-depth explanation. And I've also done one at the bottom. It says Dean on the bottom. My one's a bit better. I'd check my one out rather if I were you. But actually, there's a working example, and you can play through it. It's not really. If you wanted to experience what this feels like as a user, so you want to see this in action, this is just a demo site that I was messing around with. If you head over to this URL, it'll ask you, it'll say, hey, obviously if you're in the right browser, it'll say, hey, would you like to subscribe to push notifications? And you go allow or disallow. And then it will start. It won't send you straight away unless I send them to you, but it kind of gives you the feel for what you're looking for. All right, we're talking about engaging. We're adding to the home screen. This is the next feature we need. I'm just going to watch this short little clip. We're navigating to the Chrome Dev Summit website, and as soon as we hit it, at the bottom will pop up and say add to home screen. Now, at the time that this was recorded, I don't know if you saw that, it's going to start again and go through it. It opened it up. At the time this was recorded, the icon, just put the Chrome icon. You obviously will get the icon that you specify in your manifest will appear on your home screen. So it's almost going to feel quite appy. So if you click on that add to home screen and you go through and you've said, oh yeah, I want the standalone, and your browser back and forward bar is in there, it's all contained. And how do we do this? Well, there's a few steps that need to take place. First of all, as explained, you need a manifest file. Your manifest file needs a start URL because once you click that button, it needs to know where to go. Where do I begin? You also need an icon so that the icon can get saved on the home screen. Your site needs to be using a service worker and run on HTTPS. And this is the key part, really. Your site, the user has to have visited your site at least twice within 5 minutes, because if they do that too, and you start pinging them, we don't want to start spamming them. We want them to be happy to receive these things, and we want them to want to add it to their home screen. And this is just a super quick example. You can see in there, earlier on we didn't really go into in depth, but you can see there's a short name in there. We've got display standalone, and we've got our icons and our start URL in there. Cool. And it'll start to appear. Hooray! That's it. So let's just talk about what we've covered under engaging. We talked about the look and feel, how you can change it. Talked about push notifications and how you can add to home screen. So let's talk about speeding up your website. This is what we really came for, right? That's what, no? Yeah. Again, I've broken this down into 3 sections. I'm going to talk about caching, the save data header, and background sync. So let's start with caching. At the moment, as we all know, we have HTTP caching, and it's great. We set it on the server, it comes back and tells the browser how long to cache an object for. But now, using service workers, we actually have programmatic access for the first time to be able to decide how we want to cache. And we can add logic in there. We can start to get a bit clever. So remember, we were talking about the air traffic controller, every request coming and going, the fetch event. Well, if we wanted to, we could say, hey, don't even bother going to the server. We know what's in there. We've got you cached. So again, this is a little code sample. This is what would look like inside your service worker file. We've got a cache version in there, and I've said current cache. I've just created another variable. And what I'm doing is as soon as the service worker's been installed, I'm opening a cache. I don't know if you can see that line over there. Open the cache, and it's using the name in the current cache up there. It's saying use the current cache. Once that's done, it's saying, okay, cool. In this case, I want you to cache that CSS file and that JavaScript file. You could decide to cache manually, list this out if you know your resources aren't going to change often, or you could dynamically do this. So every time you do a fetch, you add to cache. So once that's done, for this example, it's really simple. I'm just caching because I know these aren't going to change often. You can then say, let's hook into the fetch event. And this is really where it's all at. Now that we know that we've got a cache open, let's just check if that URL exists in the cache. So that's what it's doing there. It's saying, does the caches.match the event.request? If it does, it gives us a JavaScript promises.then, return the response. But if it doesn't, just go off and fetch it as normal. So it's just going through and checking if it's in cache. If not, it's returning as normal. Pretty cool stuff. And believe it or not, it's lightning fast. It's really, really quick. There has been a pretty cool toolbox that's been created out of this. I know in that example there, you saw there was a bit of code. It starts to get a bit chunky if you start to add more and more caching. But it's called the Service Worker Toolbox. It was developed by the Chrome team. It's just a library that you add, and it really slimlines everything. So you add this JavaScript file, and it allows you to say, hey, I want to choose my caching strategy. Do I want to do a network-first approach, so always go to the network? Do I want to go offline? Do I want to sometimes go to cache? It really puts the control in your hands, and it's pretty cool. Pretty slick way to get started up with it. That shortened URL at the bottom there, that's a working example. It's a full tutorial if you just go through that, and I'll talk you through it. Okay, more performance. Save data header. If you look in your phone right now, and if you add a plugin into Chrome at the moment, and you switch it on, there is a setting that will actually say save data. So let me just explain exactly what this is all about. So I know not so long ago I was in an airport in Spain, and I had my 3G on, and it was lying to me because it said it was 4 bars, but it wasn't. And I was trying to download something, and it was taking ages, and all I needed to do was get something on the airport website, and it wasn't bringing it back. And it was taking ages. And all I needed really was just the text to come back. And this is where this is leaning, and I'll talk about it in a sec. So using service workers, we can decide what to do with that header. You could decide, hey, we've got the save data header coming through. Let's do something on the server instead. But in this case, remember, we've got service workers, so why not just start using and inspecting these headers, because we have control over them. So this is where the magic happens. Do you like that animation? Remember, we can tap into the fetch event. In this case, what I'm going to do, this isn't like super magic, and I'm sure it's not super bulletproof either, but it works, and it's pretty cool. I'm tapping into the fetch event. I'm then inspecting the headers and saying, hey, do you have that save data header in there? If you do, I want to check if you are asking for an image. If you're asking for an image, let's respond with a different URL. So in this case, I've appended the words low quality. That's not ideal, right? I'm sure there's better ways of doing that. But for this example, it's really just saying, if you were asking for dog.jpg, it's now going to ask for low quality dog.jpg. So it does mean you'd have two copies of the image on your site. And if a user has this switched on, you can now go, ta-da, I want to serve a super light image, or no, I want to serve the high quality image. And this is pretty cool because we have users around the world who pay a lot of money for their mobile connections. In some countries it costs almost some of your salary to be able to afford it. And with this enabled, it allows us to be responsible as developers. So we are thinking about our users at the end of the day. Now, I built a website around a book I wrote. Hooray! I'm not going to plug the book, but what I want you to notice, subtle, if you notice that image in the middle, it's nice and shiny and high quality, right? But with this turned on, what I did was, I took the image right quality right down. Okay, this is an extreme example, right? And I'm showing you how it really sucks. But if you wanted to view the site, it really makes a difference in how quickly it loads, because it's not asking for the full-blown HD version. So I'm sure you're thinking, oh my days, what is that, right? That really sucks. But again, the control's in your hands. You can decide, do I want to crank this image right down? Where do I want to put it? It's up to you. And believe it or not, I saved 900K. Okay, I did extremely low settings on Photoshop, and I cranked it right down. But you can, this is there. It's for you to play with. You can decide what you want to do. Okay, background sync. Anyone see what I did there? Yeah? So, using service workers, this is another amazing feature in service workers. Let's say, for example, I was on a train between Bath and Bristol, like I was this afternoon, and I tried to send something or make a post or send some data through, and I didn't have a connection, or my phone was lying to me again. If that failed, there's no reason why, using service workers, we can't respond and say, look, it took a little longer than we expected, okay, fine, but why not try later? And this is where background sync comes in, and it's pretty cool. So this is some code in the service worker. If our service worker is ready, we want to register something called a sync, and that is my first sync. It's pretty low key, but now we can start to tap into that sync event, and we can listen out for it. So once that sync event comes through, we can say, okay, let's do an expensive operation. Let's perform an expensive operation. Wait until that's complete. And what it does is that event.waitUntil will ask for a JavaScript promise. And if the JavaScript promise resolves and it's happy, it'll send something and sync it. If it fails, it'll just pop it back on the queue and wait till it has connectivity again. So it's a pretty cool way to ensure that we keep things rolling with the user. We don't drop off. So background sync. Check it out. That's the URL. It's pretty new stuff, but it's out there, and you can start using it. So just to summarize what I've talked about so far, we've talked about caching, talked about the save data header, and background sync. And finally, let's talk about part 4, reliable. This was actually me in the gym this morning. That's how I get jacked for a talk. Yes, offline browsing and third-party scripts. We want to make our site more reliable. So again, imagine I was on a train from Bath to Bristol and I lost connectivity. That sucks. Why not make our app offline? Because remember, we have control over the cache. So in the same way the service worker was able to cache and add it straight into the browser's cache, instead of just saying, hey, we're offline and let's fail and just show you the little dinosaur or the no load page, we can decide what we want to do because we've tapped into the fetch event. Again, showing the fetch event, we're listening out for it. We can say, hey, we're doing a get. We also are looking for an HTML page. So we're navigating and we're looking for an HTML page as we're doing a get. We can decide how we want to respond. We could say that if we try and do a fetch and it fails, if it gets an error, why not just go off to the cache? You can see over there it says the offline page. The cache is just a string. You can name the cache whatever you want. That's why if you remember back to the other example, there was a variable that changed. So every time you wanted to change the cache, you just up the number and you wouldn't have to change the string every time. But in this case, this is what you could do. And I know at the moment, The Guardian actually has, if you go offline, you can play crossword puzzle. You can just have a little bit of play around. So you don't, the user isn't able to do everything that they want to do, but they still feel like they're connected, which is cool. If you'd like to experiment with this, there is a course where, that video with the service workers and the big drama, that's where that URL actually comes from, offline-apps. And there's a course, I think it's with Jake Archibald, and it's a complete course. Will teach you how to build an offline application. It's pretty cool. I haven't done it, but I watched some videos. It looks good. And also, I created a simple example there, a bit.ly/offline page. That is a simple web page, and it teaches you how to do this from scratch. Okay, third-party scripts. This is Andy's favorite. So what happens if you have a Google Analytics script at the bottom of your page, and Google goes down? Well, it's called a single point of failure. And what happens is the site hangs. So let me just show you what happens. On the left-hand side, you can see that's the original site. It's loading up really quickly. 3.6 could be better, right? But on the right-hand side, Google servers are down. We're waiting for a response. It hasn't responded. It's keeping us hanging. This goes on 12, 13, and this can happen to any one of your web pages right now if you haven't thought about this. And this is any third-party script, anything. Facebook like buttons, Twitter share buttons, you name it. And that sucks as a user. It doesn't happen often, but it can happen. But remember, again, we've got service workers. We're in control. We own the network. If the server goes down, we can decide how we want to respond. So this is a little bit of code. It's really just a JavaScript timeout. And what it's doing is it's saying, pass me in a timeout, a delay. And if you aren't happy, return a response of 408. So at least something comes back. It's better that we bring something back to the user than absolutely nothing at all. And the browser knows what to do with that. And again, we've got the fetch event, tapped into the fetch event. And this is getting a little crazy here, but at the bottom it says event.respondWith, and it's got a promise.race. Now this is a race condition that basically compares two methods. Whichever one comes back first, not methods, functions. Whichever one comes back first will win. So in this case, on the one side, we're passing through a timeout of 6,000, so it's going to execute that function above it. Or we're saying go off and fetch the URL. So it's going to go off and fetch. Does it take longer than 6 seconds? Yes, it does. Give me a 4.8. Or no, it took 3 seconds, and then give us back what we expect. Now, you could actually extend this further and say, well, I wanted to do a performance budget and always make sure that something comes back within 10 seconds, for example. And this wouldn't just be for third-party scripts. You could, cut off straight away. It's really up to you. I put 6,000 because that's 6 seconds. It's up to you to play with. And this example is live at SW-timeout. And that's it. Let's just summarize what we talked about. We've talked about how you can understand what progressive web apps are, how you can use them to engage your users, how you can make your website faster and more reliable. But remember, performance is still a feature. We can't walk away from these things. I know, we talk about service worker and it's pretty cool, but all the things that we do right now are still really important. Optimizing our images, making sure our CSS and JavaScript is fun and awesome. It's really important. So don't leave it. Again, I'm going to throw loads of URLs at you, but you can check out these slides. This is some further reading. On the code labs, there's actually a full code lab which you can follow along with, and it teaches you from the scratch. You download the repo and you just get started. And then there's also some recipes in there. Mozilla have some cool recipes where you just click on the link and it'll show you the service work and the different ideas that they've done. Very, very cool stuff. But what's still to come? There is some even funner stuff. There's web Bluetooth, and this is all part of the W3C. It's on the way. We've got Streams API. We've got Web NFC, which is near-field communication, and also geofencing. And the idea behind geofencing is if you're a user, you can start to bucket them based on where they're from, which is pretty cool stuff. So thank you very much. I hope it's been useful.